This is homework 4, question 2.46. Here's a given equation. Here's a Laplace transform of this equation, rearranged to get this form. And you will then rearrange this to solve for x of s, and you'll have this equation. Solving for these roots, you'll get this imaginary root and this complex root. Using this chart, you can get this form of partial fraction decomposition. You'll move this denominator over to each of these terms and get these equations. Solving for the coefficient equations for each similar power in each of these equations, you can get this coefficient matrix. Solving for that, you can use this chart after plugging these coefficients into these equations to get this final form for x of t. And then problem 2.16a, you start with this equation, again put it in Laplace transform form, and solve for x of s, finding those roots. You should be able to get this form of partial fraction decomposition, and then you'll take the limit as s approaches the 0 of each of these roots, and take away this bottom position in this fraction, and then plug in 0 as you would for any limit. And then you'll end up doing that for all 3 of these coefficients and get c1 equals 2, c2 equals -3, c3 equals 6. Plugging that back in, you can use this chart once again to get this form for your inverse LT.